you are at the Data-Enabled Computational Engineering and Science info session. Thank you all for joining us here tonight. I'd like to make a few introductions, and then I'm going to go over the basics of the format of this session, and then we're going to get down into the actual content. So first of all, I'd like to introduce Professor Yuri Bazilevs. He is one of the academic co-chairs of this program. He has worked on building the creation of this program, all of the content of the program. He's a great person to ask all of your questions to. So he's going to be giving us quite a few of the slides later on tonight. And I'll let him just say hello quickly.
Hello, everyone. Glad to be here.
Great. And then I'd like to also introduce Victoria McCready's. She is our enrollment manager for this program, and she works closely with us. She can answer any questions as you're going through the application process about the system, questions about what you're seeing on the website, if anything's not making sense to you, or questions about the timeline. She's here with you every step of the way from when you first say you're interested in the program through getting that application to us. So I'll let Victoria say hi.
Hi, folks. Thanks so much for coming tonight.
Great. And then I am Jennifer Cassanto. I'm the Associate Dean in the School of Engineering, and I work on new graduate programs, and I support all of our graduate students here in the School of Engineering. I also work on outreach for students interested in applying to our programs. And then this is the table of contents, if you will, what we're going to be covering in this info session tonight. We're going to go over the program structure, including the fundamental topics of the program, the curricular highlights of the program, and the prerequisites, what we're looking for if you're applying to this program. And then we're going to go over in detail the application requirements, including, of course, the deadlines, what's required to apply, including your personal statement, your letters of recommendation, and then the tests that we require for this application and how you get those tests sent to us here at Brown University. So we're going to go through all of those topics, and then we're going to save time at the end for a Q&A. So I think we're ready to kick things off. So next slide. I'm going to hand things over to Professor Yuri Bazilevs, and he's going to go over in detail some of the program content.
And let me start with a couple of motivating remarks. Sort of from my experience, after graduating in engineering with a bachelor's or perhaps a more advanced degree, there's a very high chance that your employer will task you with carrying out advanced engineering analysis work. Okay, what do I mean by that? So some examples may be, if you go into aerospace industry, chances are you'll be simulating vehicle aerodynamics or maybe aeroelasticity. In fact, a lot of the wind tunnel testing these days, vast majority of it is replaced by computer modeling, where you're solving fluid flow equations over aircraft bodies. You may be analyzing mechanical fatigue or failure of aircraft or rotorcraft components. You may be looking at impact damage, for example, bird strike on an engine or sort of a mild hit of a luggage cart on the aircraft body and see what kind of damage that generates. If you go into mechanical industry, chances are you'll be simulating car crash for safety certification. If you're considering a career in biomedical engineering, you may be looking at simulating medical devices, things like operation of blood pump and prosthetic valve designs. If you're interested in national lab or defense type path, there's a chance you'll be looking at simulating, various aspects of weapons deployment or penetration, things like ballistics. Okay. If you're interested in computer hardware, you may be involved in simulating coupled thermomechanical processes and electronics packaging. Okay, and so the list sort of goes on and on. And the aforementioned applications involve time dependence, multiple coupled physics, complex geometry, non-standard time-varying boundary conditions, etc. The methodologies used are typically finite elements. Chances are you'll be carrying out a lot of finite element type calculations or related technology, and the use of very sophisticated commercial or in-house programs, or some combination of the two. Okay. Now, artificial intelligence, although considered to be an area of computer science is also starting to play a significant role in the realm of engineering analysis. More and more costly advanced computational models are supplemented with data-driven techniques, okay, like those based on neural networks, to get predictive power at a fraction of the cost. And although these developments are in their infancy as far as engineering analysis is concerned, they will likely be an important part of engineering simulation going forward. Okay. Now, traditional undergraduate programs in engineering, applied math, or physical sciences related disciplines typically do not adequately prepare students to sort of competently carry out such analyses. Also, most Masters of Science programs tend to further specialize in relatively narrow disciplines and don't provide the right sort of constituents to produce top-level computational engineers and sciences. And so it's precisely these considerations, and together with the presence of a critical mass of competent faculty at Brown, that have led us to develop and offer this Masters of Science program in the data-enabled computational engineering sciences. So let me speak briefly about the program goals, okay? And the program was designed to train students in the following: gain the understanding of a significant role that advanced and data-driven simulation plays in industry and national labs, as I alluded to in my remarks. Develop an appreciation for the power of multi-fidelity and data-driven modeling and simulation in contemporary engineering design. Gain technical knowledge of the foundational aspects of computational engineering, including nonlinear finite element analysis and the integration of machine learning and data science, and develop, this is probably most important, develop the necessary technical skills and expertise to knowledgeably carry out practical engineering scale, data-driven inference and simulations. Slide. So here's some program and curriculum highlights. The start date is typically September, so we start in the fall semester. The students will take a total of 8 courses over a maximum of 4 semesters. And of course, the program length depends on the student chosen sequences and individual circumstances, but the likely scenarios are that a non-thesis sequence will take you about 3 semesters to complete, and a thesis sequence, where you actually produce a master's thesis, will take you about 4 semesters to complete. As far as prerequisites are concerned, a bachelor's degree in engineering, physical sciences, natural sciences, related subjects is what we'd like to see in the applications. And it is best fit for students who have received their bachelor's degree relatively recently, say in the last 5 years. Some of the courses in the program, as I've alluded to earlier, foundational sort of theoretical things that you need to know. And it's good that that knowledge from your BS degree is sort of fresh in your mind. Slide. Okay, so the 2 options, right? Let's talk about a Masters of Science and non-thesis option, and this is going to be likely the option for most students. 3 semesters, you can take 3 courses in the first and second semesters, and then 2 courses in the third semester. So if you start in the fall, you'll go through fall and spring. This will enable you to perhaps do an internship in the summer, come back and finish the degree. For more advanced, well-prepared students, a 1-year completion is also possible, but you'll have to take 4 courses in each semester, which is quite a load, but it is doable. Okay? And as I said before, maximum duration is 4 semesters for the program. Slide. The thesis option, which is likely will be taken by a smaller percentage of the students. There we're looking at a 3-semester program where students take 3 courses in the first semester, 3 in the second, and 2 in the third, okay, 3-3-2 model. But the difference here is that in the second and third semesters, you may be able to enroll in the so-called reading, research, and design, right? There's an engineering designation or applied math designation for that class to satisfy the 8 course requirements. So basically, this is your chance to develop and write your thesis. There's also a 4-semester option for that. It's not likely that you'll complete the thesis option in 2 semesters. The most important thing is that no matter whichever case you take, the reading and research and design course may be counted up to times towards the degree. Slide. So as far as the program is concerned, right, the idea is to sort of produce a well-educated computational engineer, computational scientist, right? And so I can say that the program was built around sort of three pillars, right? That in my mind define a computational engineer, scientist. First is your engineering specialization of choice, right? So students coming in are sort of already likely know which way they would like to go. They may want to study solid mechanics, or they may want to study topics on chemical engineering, for example, right? So this will define your curriculum largely, right? Then you'll be asked to take classes in applicable mathematics and numerical methods, computing, to supplement your engineering area of choice, such that you know what kind of methods you want to use for the kinds of problems that you want to solve, right? And the third area is data science and maybe more general high performance computing, where you will receive appropriate instruction and introduction to data science techniques, and we'll try the best of our ability to make a connection as to how that relates to engineering, engineering analysis. Okay, so you'll end up taking 2 courses on engineering, 2 courses on applied math, 2 courses on data science / HPC, right? And then you will select 2 more elective classes. You can either kind of to beef up any one of the areas you may be interested in. Okay, so some courses are listed here. 2 of them are designated as a core, but it doesn't mean that you have to take it. Okay, what we mean is very likely a large majority of the students that are enrolled in this program likely will end up taking a course in continuum mechanics. Doesn't matter if you're interested in solid mechanics or fluids or maybe some biomechanics. It's important to understand some of these mathematical descriptions of how objects move under the action of various forces and so forth, right? And then we have a variety of sort of classes that could fit either in the engineering specialization, computing, or data science area. If you're more mathematically oriented and you want to understand the foundational theory behind finite elements, you would take Hilbert spaces and applications in the Department of Mathematics. If you're interested in data, of course, it's important to understand probability and statistics. If you're interested in things like solid mechanics, you take classes in linear elasticity or fracture, right? If you're interested in AI methods and algorithms, you would take a course on pattern recognition and machine learning. We also have another exciting development where my program co-developer, Professor George Karniadakis, is actually developing an exciting course in collaboration with NVIDIA, where he's blending data-driven techniques and partial differential-based modeling, to apply to the analysis of engineering systems. Slide. Okay, so what makes a great candidate, right? On the prerequisite side, you will be looking at the GPA, although it's of course not the only criteria. I think the admissions committees will be looking at grades in relevant, introductory, or intermediate coursework, which helps kind of demonstrate us the basic preparedness for the students. Work or research experience is not required. However, if you do have that experience, it helps demonstrate your ability to handle graduate level research materials. So if you have it, please showcase that in your application, right? Having specific goals for how you want to apply your master's degree are important, right? Having chosen a particular area of sort of engineering or scientific specialization, right, would be very important. Kind of the rest of the program will come together very naturally for you, okay? And your statement of purpose is a great way to showcase your goals and aspirations. And of course, we'll be looking for strong letters of reference with detailed factual and candid evaluation of your capabilities. And with that, I'd like to give it back to Jennifer.
Yeah, great, thank you. So we wanted to get into a little more detail into the application requirements, so slide. First of all, the application deadline for priority consideration is February 1st. What that means is if you can get your application in, maybe work on it over this winter break, if you're finishing up your undergrad program, or if you have some time off from work, and get that into us by on or before February 1st. We're going to review all the applications we have in at that point, and we're going to make our first set of admissions. If in that first wave of applications, we have, really, really strong applicants, and we fill up the program, 2/3 of the way or almost all the way full with that first wave of applications, anyone who continues to apply through April 1st, we will absolutely consider your application. Please go ahead and apply, reach out to us, let us know your application is coming, but we are going to make offers in our first wave of admissions around that February 1st date. So please get your applications in then, and we will do rolling admissions through April 1st. We will read and consider any applications that come in all the way through April 1st. Then what you should be gathering together to get ready to apply: a copy of your transcripts, your CV or your resume, and your personal statement, which should not be longer than 2 pages in length. And we're going to go into this in a bit more detail in the next slide, but what we're looking for in the personal statement and some tips around how you could be writing it. We'll talk about that a little bit more. Then you're going to need 3 letters of recommendation. We're going to go into that in a little more detail. They should all be from ideally people bringing different perspectives on your abilities and maybe your past performance. And then we are also going to require a TOEFL test for applicants whose native language is not English. So only those whose native language is not English, and the GRE, the general GRE, we do require for admission. Next slide. So the personal statement. This should be 1,000 to 1,500 words. So, really not that long. We really encourage you to start early. This is something that you could be drafting or sketching out. You could certainly show it to, if you're in a undergraduate program and you have a writing center, it could be a great thing to show to the people there. You want to be going through multiple iterations and really fine tuning that. Some of the things that we would like to see in your personal statement is how you would fit with this program of study. So what are your reasons for graduate study in this field? What are your academic goals and your plans if you were to get admitted into this program at Brown? But then also, do you have any ideas, even general ideas, big picture ideas about the issues or problems that you might want to work on after you complete this degree? Your career goals: how does this program fit into your professional future? If part of the reason that you are interested in this program is it would mean a potential advancement, a promotion, it's an area that you just got promoted into and your organization is hoping for you to expand in this area, all of those would be great things to share with us. It really helps us see how this program is in alignment with your goals and your skills. Please don't simply repeat what you have on your CV. You should really put some content around all of these things. And then for your personal statement, many versions, edit, revise, show it to your friends, and consider that this is also your writing sample. So it should also be something that's well written, grammatically correct, does not have any mistakes or typos. We really want it to be very well polished. So please ask for another person to review what you've written and get it to be your best version of your writing. Next slide. For letters of recommendation, 3 letters are required, and we suggest that you choose people that you know well. So specifically, if you're thinking the highest grade you ever received was with a professor that you have not, for example, seen in 10 years or spoken to, that may not be the best person to write your letter of recommendation. So really thinking about who knows you well, and then reaching out to that person early. Every faculty member or even supervisor or anyone who might be writing letters of recommendation is inevitably writing them for many people. You're not the only letter that they have to work on, and many application deadlines are similar. So each person you ask to write you a letter might be doing many of these on the same deadline. So if you think you're going to be applying, it doesn't hurt to reach out to your potential recommenders now to let them know of the requirements and potentially even list them on your application now, even if your application is not yet completed. Then what we're looking for, from the letters of recommendation is different perspectives. And this is why we say be strategic in who you ask. You could have one come from a supervisor who can really talk about how you apply knowledge in trainings or in the knowledge that you received in your undergraduate degree. One of the letters of recommendation could be from a faculty member who taught you in a class and can really talk about your academic performance. Or it could be you worked with a professor in their lab and had a research experience. That would be a great person to write a letter of recommendation and talk about your passion for research in this area. So when you reach out to these people to ask for the letters of recommendation, please suggest to them why you're asking them, that you want them to talk about research, that you want them to talk about your academic performance. Don't have them just guess what you're asking them for. And you should always be giving that person a current version of your resume. And if you have a draft of your personal statement, that's a really nice thing to share with someone who's going to be writing a letter of recommendation for you. First of all, they might give you feedback on that, but it helps them write a really strong letter that's in good alignment with when you're talking about your goals for the program. It's something that they should know when they're writing a letter of recommendation for you. Next slide. So I'm going to hand it over to Victoria, and she's going to go over some of the details and structures around the test requirements. Go ahead, Victoria.
Thank you so much, Jennifer. So I just want to talk a little bit about our testing requirements and how you can get us those testing scores. The first test that we will talk about is your English language proficiency exams. You can satisfy an English language proficiency requirement with one of two exams, the TOEFL or the IELTS. So for anybody who doesn't speak English as their native language and doesn't have a degree from an English language speaking institution, this will be a requirement that populates as a part of your application. Now, if you feel like, based off of what I said in this presentation, or maybe what you've read online, that this requirement shouldn't apply to you, but for some reason does, of course, you can always be in contact with our office and we're more than happy to assist you. But that's sort of generally how we work through things. Now, we accept the at-home versions of both the TOEFL and the IELTS. So if you are concerned about going to a testing site, or if you don't have access to a testing site, those are both really great options for you to be able to fulfill this testing requirement. You can see also what the recommended minimum scores are for those exams. Really, the purpose of this test is to make sure that the students that we're admitting are going to be successful in an academic setting with their English language skills. And then to send us those scores, the TOEFL school code is at the bottom. And if you can't find that, you write it down, you need access to it, just shoot us over an email and we'll be happy to get you those school codes. Next slide. And then the GRE, Jennifer did a great job of sort of talking about what the GRE requirement is. Again, the at-home version is acceptable for the GRE if you're having difficulty taking the exam. Waivers may be granted. That's very much on a case-by-case basis. And then the graduate school code is right in front of you. So again, if you're not able to find that code, just let us know. We want to make sure that you don't have any administrative blockades to submitting your application completely, right? So just be in contact if you need any of that information. There is a holistic review process. We talk a lot about testing, especially sort of at the tail end of this presentation, but also just keep in mind the things that Jennifer has said about the qualitative components of your application and your academic record that also come into play when the faculty review committee is reviewing your application.